Hello, Professor Sargent here with you again. It's been a while. We have this problem here that I've shown two different ways to solve previously, and I've come up with yet another. I'm going to save for the end some cautions and a discussion of the inspiration, as well as where things are going to go next. So let's get right to it. Suppose you need to solve an equation with two square roots, either of the form square root of a plus square root of b equals c, or in case two, such as the one shown here, the square root of a minus the square root of b is equal to c. Let's take a look at case one first. What I'm going to do is multiply both sides by the conjugate of square root of a plus square root of b, namely the square root of a minus the square root of b. So that's on the left-hand side, we would have the square root of a squared minus the square root of b squared. Distribute on the right-hand side. And squaring the square root of a and the square root of b, we'll have a minus b equaling c squared of a minus c squared of b. On the other hand, taking the same original, multiplying both sides by c. However, I'm going to write it this way. I'm going to switch the left and right hand sides here. Multiplying both sides by c. So we have c squared equals c squared a plus c squared of b. And what I'm going to do is add c squared plus a minus b and add c squared of a minus c squared of b to c squared of a plus c squared of b. The c square roots of b, they are opposite signs, so they'll cancel. And we have 2c squared root of a. I'm going to copy that over up at the top left and look at what we would get by multiplying both sides in case two by the conjugate, as well as multiplying both sides by c. In case two, multiplying by the conjugate, that conjugate is going to be square root of a plus square root of b, and we will get a minus b again when applying the difference of squares, but then distributing c to that conjugate on the right-hand side, we have c squared of a plus c squared of b. But then when we multiply both sides by c, again, I'm switching the left-right order of the equal sign versus what we saw at the top right there. Distributing. And again, we will get the c squared of b, since they are opposite signs, canceling out. Adding together, we again get c squared plus a minus b equals 2 times c squared of a. Now we just have a single square roots. Squaring both sides. I'm going to handle this a little bit differently than you might expect, though. on the left-hand side, squaring c squared. C squared squared is c to the fourth. We'll have plus 2c squared times this quantity, a minus b. And we will have the quantity a minus b squared. For lack of a better word, distributing the squaring to the individual factors here, 2 squared is 4. Got c squared there, and square root of a squared is going to be a. Distributing the 2c squared in that middle portion, 2c squared a minus 2c squared b plus that quantity a minus b, all of that squared equaling 4c squared a. Subtract 2c squared a from both sides to give us a 2c squared a on the right, and add 2c squared b to the right-hand side. And I'm going to factor out 2c squared on the right-hand side. That is the format in which I've been writing this formula that I've developed. And again, because we showed case 1 and case 2 both lead to this line right here, then both case 1 and case 2 will lead to the formula. So now let's apply this to the example shown up here. All right, so I've stated that the equation that was given was in the form of case 2, so that we have that a is 3x plus 3. B is the x plus 10. And c is 3. So the easiest part to deal with here is what's c squared and what is c to the fourth. Next, a plus b, what we have over here, that would be just a nice matter of combining like terms. 3x plus x will give us 4x. 3 plus 10 will give us 13. Obviously, we need to be a little more careful with a minus b. 3x plus 3 minus x minus 10. We'll have 2x. Oops, plus 10 there. And minus 10 here. So 3x minus x will give us 2x. And 3 minus 10 will give us a negative 7. So 2x minus 7. All right. All right, so we are looking then at 81 plus 2x minus 7 quantity squared equals 2 times c squared. That's going to be 18. A plus b, we had that was 4x plus 13. Squaring the 2x minus 7. Plus 81 plus 4x squared minus 28x plus 49. And we also need to see what 18 distributed to 4x plus 13 is. All right, well, combining the like terms on the left-hand side, first of all, 81 plus 49 should be 130. 18 times 4, that's 72. As for 18 times 13, 18 is really close to 20. 20 times 13 would be 260. We're multiplying 13 by something 2 higher than what we wanted to multiply it by. 2 times 13 is 26. So 260 minus 26 would give us 234. Finding like terms, subtract 72x from both sides. Negative 28 minus 72 will give us 100. So 4x squared minus 100x. And then 130 minus 234 would give us negative 104. Dividing all terms on both sides by 4. Dividing all terms on both sides by 4, we get that 0 is equal to x squared minus 25x minus 26. And that's something that factors nicely. X minus 26. That quantity times the quantity x plus 1. So by the zero factor property, either x minus 26 is equal to 0 or x plus 1 is equal to 0. The first giving us that x equals 26, and the second giving us that x is equal to negative 1. Checking the first solution, 26. 3 times 26 is 78. 78 plus 3 is 81. 26 plus 10 is 36. So we have square root of 81 is 9. Square root of 36 is 6. 9 minus 6 equals 3. That checks out. Checking x equals negative 1. Three times negative 1 is negative 3. Negative 3 plus 3 is 0. Negative 1 plus 10 is 9. So square root of 0 is 0. Square root of 9 is 3. If we had been adding 0 plus 3, then we would get this to check. But negative 3 does not equal positive 3. So our only solution is x equals 26. Okay, so caution. I've not seen that formula before. So using this approach, I would be very cautious about using it. Maybe develop the formula first and then plug things in. Maybe this is something that will become widespread. I have no idea. Inspiration. There's an inspiration I'm going to hold back on for the time being until I film some additional parts. But I'd actually tried to record this a few months ago and I wasn't happy with the outcome. So I'm redoing it now because another math content creator, A+BI, or you may know him as Cybermath, had a question involving complex numbers, and I got a surprise where I applied this formula to one of his questions where the inputs and outputs were complex. It was still working. As for where this is going next, I'm going to show some other algebraic methods and something that is hidden behind this. Another method for developing the formula. That's all for now. Take care, stay healthy, and I'll see you in the next one.